congestion control in a TCP, that is transport layer. It's a main mechanism, is a congestion control. So congestion control means when we are transferring the data from source to destination, it's some reasons it's occurring the traffic. So based on that, we have to control the congestion in some mechanism. So here the congestion control is a mechanism to ensure the reliable data transmission. That is, when we are transferring the data from sender to receiver, it transmits the data. First is to establish the connection. After establishing, it's transmitting the data. After getting the acknowledgement, it transmitting the original data. Again, it's sending the acknowledgement to the sender side. So it's having a three-way handshake method to establish the connection and transmitting the data in a TCP. Okay. So here it's dynamically adjust the rate of a data transmission. That is, we can regulate or we can adjust the rate of the data transmission to transfer the data from sender to the receiver. So based on that rate control, we can control the congestion. That is, we can avoid the traffic occur. So here we are using a mechanism like slow start, then congestion avoidance, fast retransmit, and a fast recovery. So first we are going to say about a slow start. Slow start means based on the timing, we are transferring the data. When we are sending the data from sender to receiver, it's having some time limits to start. Again, it's sending the data in a slow manner. So if it is not receiving in a receiver side based on some time limit, again we have to resend the retransmit the data from sender to the receiver. So likewise, the congestion avoidance. So we have to detect, after that we have to avoid that congestion in a sender to receiver manner. Okay, so congestion avoidance method, we can use the many algorithms to avoid the congestion when we are transferring the data from sender to the receiver. So it's reduce the delay and the packet loss and increase the throughput. Okay, based on that, we can improve the performance of the sender to receiver data transmission. Send fast retransmit. So based on the time limit, we can control the packet transmission from sender to receiver. So when it's occurring, the more packets are sending in a particular manner, particular time limit, that time it will occur the congestion. So we have to avoid that congestion. Okay. So after that, fast recovery. That is, it's sending the data in a fast manner from source to the destination. That is, it will increase the window size. Based on that, it transmits the data from sender to the receiver. Okay. So we have to control the congestion. Why we have to control the congestion means to prevent the network overload. When the congestion occurs, the overload will be happen. So we can avoid the overload of a network. So we can prevent the network overload. The next one is fair sharing of bandwidth. That is, bandwidth means in a some frequency manner, we can transmit the data from source to the destination. So we can easily sharing a bandwidth, that is fair bandwidth allocation. Based on that, we can control the congestion. For example, if you are giving any size of a buffer, so in a particular size, the packet will be accepted. Again, we can send the more packet means the buffer will be overflow. That time the congestion will be occur. So by using a fair bandwidth allocation, we can avoid the congestion. Next one is improve the throughput. So by avoiding the congestion, we can improve the performance of the network on the throughput. That is, we can avoid the packet loss and delay and increase the throughput and end-to-end delay also. So delay means based on a timing, we can transmitting the data from sender to the receivers. Okay. So by these reasons, we can control the congestion. So by controlling the congestion, we can improve the performance, that is increase the throughput and reduce the time delay and reduce the packet loss. So these are all the parameters of the congestion based manner. Then we can avoid the congestion. Based on that, we can prevent the network overload. So for example, in a real time, if you are taking when traffic occurred in a signals, so based on a signal process, we can transfer the vehicles in a particular time limit in a particular way. So that's the same concept here also. We can transmit the packets from sender to the receivers. Okay. Thank you.